All right, good morning. And I hope you guys are doing well. I appreciate your flexibility in joining me online today. I had every intention of getting to campus, but the traffic this morning was just nuts, and I couldn't even make it a few miles out of away from home. So I turned around because Google Maps said, there was still like another hour of driving to do. So anyway, I have posted this page on the midterm exam and your note sheet. So you are allowed, everyone will be allowed to have one sheet of notes, letter-sized sheet of notes. Make sure your name is written on the your note sheet. You are allowed to write on both sides of the paper, and I will collect the note sheet. So make sure you put your name on it. The note sheet can be handwritten or it can be typed, or you can create it digitally with your iPad or whatever. My requirement is that you have to create the note sheet yourself. I don't want people to just make photocopies of their note sheet for someone else. If you want to work with a classmate or whatever to create your note sheet and decide like these are the important topics to put on the note sheet, that's fine, but you do have to make it yourself. Okay. Now I will include this regular expressions cheat sheet. Okay. So you can take a look at this. This will be included with the exam. And so there will be, maybe a couple questions on regular expressions. Um, but this will be included. So you don't have to put all of the regular expression stuff on your note sheet. So that will be included with the exam. Okay. Um, but other than that, that's what you have for the note sheet. I have posted an old exam from an old midterm exam. Now, of course, the upcoming midterm exam will be different, so don't expect everything to be the same. But some things there will be certain ideas that are similar in that, like, I will have some code written, and you will have to figure out what this code will output, right? And so some of the things are going to be dealing with scoping and, variable names. So here's a function of y, and what is this going to return? It's going to return 2 times x, and because x is not defined inside this function, it's going to search the parent environment. The parent environment of f is the global environment, so it's going to return 2 times 3, and this will return 6. Okay. And if you aren't sure, if you want to kind of, as you're practicing and you want to see like, oh, is that what's going to happen? You can what do you call it? Just kind of highlight the text, and then run it in R to kind of verify if that's what the output is. So there, now the format of the exam might change a little bit. This is almost all entirely like, here's the code. Oh, so here, if I put this, I'll paste this in, and yes, this outputs 6 into the output there. So the format of this entire exam is just like, what is the code going to output? And I do expect a lot of the exam to be written similar to that, but there might also be a few like multiple choice questions, just kind of conceptual questions asking about things. But a lot of it will focus on, like, do you understand what this code is going to output? Because I do believe that is an important skill, is being able to read code and know what it's going to do, as to be an effective coder or programmer. Um, as you are reading and debugging, you have to be able to kind of keep track in your head, as I'm reading this code, what is this code doing? Okay, so anyway, that's the description of the midterm exam, and that will take place next week. Okay, I don't know if you have any questions, but we'll go ahead and jump in. Again, if you have any questions, just throw them in the chat. Um, all right, today I want to talk about the R6 object-oriented system in R. So on Monday, we introduced object-oriented systems, and we looked at the S3 object-oriented system. S3 uses generic function or object-oriented programming, and R6 uses encapsulated OOP. Okay, and what encapsulated means is that the methods, the different functions that are specific to objects, those methods belong to the object versus, S3 being generic function. Those methods, the methods belong to the functions. Another important thing is to remember that R6 objects are mutable, okay? Meaning that they are modified in place and they have reference semantics. Um, and to kind of get started with R6, you have to load up the library R6. And if you don't have that, you might have to install .packages R6 to get that installed on your machine. Okay. I know you guys are wrapping up homework 3. Homework 4 will be posted, and homework 4 will be entirely on kind of using object-oriented programming using R6. Okay, so let's talk about classes and methods in R6. The creation of a new object class in R6 is done with this one function, R6 class parentheses. All right, and this is pretty much the only function from the R6 package that you will use. But when you use that, it implements all of the other stuff that I guess comes with the R6 package. But this is how we define new classes. But this is how you're going to interact with it. The function takes in these two arguments. You need to provide it the class name, and this is going to be the name of the class that you're defining. By convention, R6 class names are written in upper camel case. Camel case means new words. To distinguish new words is you use a capital letter. So, upper camel case is 3 words, and the capital C in camel and the capital C in case, or the letter in case is capitalized. The other ones are lowercase. And it's kind of the idea that like uppercase are tall and lowercase are short. And so you kind of end up with these humps. And upper camel case means the first letter is uppercase. You also have lower camel case, which means the first letter is lowercase. And then the other field or the other argument you pass is a list called public. And this is going to be a list of methods and fields that belong to the object. And by convention, we use snake case. Snake case means we use underscores to separate out the words. Again, this is convention. So R is technically not going to produce an error if you don't follow the conventions, but just to kind of make your own code readable for yourself and for others, you should follow the conventions. Okay. And the convention is also that you should assign the result of the R6 class into a variable with the same name as the class. And that's going to create basically the object generator, okay? An R6 object that is going to define the class and generate new instances of that class. So for example, a very simple R6 class that we will define here is the accumulator class, okay? And so we are going to provide the argument class equals accumulator. We call R6 class to define a new instance of a new R6 class object. And then the class name is going to be accumulator. And notice I store the whole thing back into accumulator. So we want to kind of make this thing have the same name as that thing, okay? And then the other argument we pass is public. Public is a list. And inside this list, I have 2 things. I have sum and I have add. Sum is a field. It is a value. So here sum takes on the value 0. Add is a method. It is a function. So I have 1 field and 1 method. Okay. So add is a method. It is a function. This function takes in an argument x equal 1. And what it does is it takes the value of sum, adds x to it, and stores it back into sum. Now, you'll notice we have self $ sum, and this means use the field value sum here inside the object itself. Okay, the object itself we're going to call is self, and so we have self $sum. We add x to it, and we store it back into self $sum, and then we return itself invisibly. But this is just a very simple class called accumulator, one public field sum, and one public method called add. So once we do this, then capital A accumulator is what we call an object generator. So you can imagine it's like a factory, okay? And you have a machine in the factory, and every time you push the button on the machine, it creates an object, uh, an instance of whatever, that factory machine is, right? So if you have the dice machine, okay, so just imagine a cartoon where you have like this big machine and there's a conveyor belt rolling out of the machine, and it's the dice creation machine, right? You push the button, and every time you push the button, a new die rolls out on the conveyor belt. You push the button again, and a new die comes out. And the same idea is here, okay? This accumulator, the accumulator object generator, is like that factory machine. You push the button, you call $new, and it's going to create a new instance, a new object, okay? And a new accumulator class object there. And so uh, this is the object generator, and it gives us information about the kinds of objects it's going to generate. And accumulator class objects will come with the field, the public field sum, and the public method add, also a clone method, which I'll show how that works in a moment. Okay. All right, so how do we use it? That new class? Well, we call $new. So this is like pushing the button on the factory machine. So we call accumulator $new, and this creates a new a new object rolling off the conveyor belt, and we are going to call that thing X. Okay. I could call accumulator $new, and it would create another thing, and I would have to probably store it, and we'll call it, Y or whatever. But here, X is going to be I push the machine, the object's rolling off the conveyor belt. We're going to call that thing X. Okay. So X is an instance of the accumulator class. Okay. X is the thing that the object generator has created, and that is going to be an accumulator class object. Okay. And so X, if we ask, all right, what are the details of X? It says, well, that's an accumulator. And you have the method add, that's a function. The method clone, that's a function. And then you have the field sum, and that's going to be the value 0. And then you can say, well, okay, I want to get the value sum from X. Okay, you can do that using $X $sum gives you the value of whatever that field is, and says, yeah, the value there is 0. Okay. If you want to call the method, you can also do that. Call X $add. Okay. The default value of X $add is to add 1. And remember, under the definition, we take the self $sum, the field sum, and add X to it, update the value sum. So when I call add, it's going to add 1 to it. And so X $sum gets updated to 1. I can call add 3. Okay, we're going to call the method add 3 here. And so that is going to update the value of $sum. So we have X $sum now has the value 4. Let me, oh, I must have accidentally closed. Let me give you your first view quiz answer. Week 5, Wednesday. All right, your first answer is the letter B. B as in bear. B as in bear is your first view quiz answer. Okay. This is the definition of the add method inside our accumulator class. And so, we take the value of sum, that field sum in itself, add X to it and do that. But you'll notice this last line says invisible self. Okay. So that returns the object itself. Okay, so invisible self means return itself, but it returns it invisibly. Okay, so even though this object is returned, um, it doesn't print anything out when it returns the object. So normally, when you return a value in R, and you call the function or something, then it prints it out to the screen. But in this case, invisible self means return the object, but don't print anything out to the screen. Okay. All right, but the reason why we want to return the object is because then the object itself gets returned, and then we can chain methods. So for example, um, I have the object x. Okay, I can ask what is the value of sum here, and right now the value of sum is 4. I can call x $add 10. And the result of x $add 10, it's going to take 10, add it to that sum field, and we get 14 in the sum. And this entire thing returns the object x itself. So this entire thing, we can think of it as just the object. The object x itself gets returned invisibly. And so because of that, the object itself gets returned, I can also add 10 to that. I can call the method 10. So here I can chain one method right after the other. And so this object itself is returning itself entirely. And I can ask, okay, well, what is the value of sum now? The value of sum now is 24, right? So because the method returns invisible self, this call returns the object itself after running the add method. And we can kind of call the add method again and again and again. And then finally we can call sum or ask for the field sum, and this has the value 24. Now, for readability, we often recommend putting each of these methods, if you're going to chain a bunch of methods together, to kind of put them on their own line. So x $sum has the value 24. If I want to chain add 10 and add 10 again, I can do x $, and then R will ignore the space in between $, and the next line. So I can do add 10, $, and then add 10, $, and then sum. And so each of these things get their own line. Total value of sum is now 44. Um, the initialize method, okay, is a method that you can define. And what this will do is it overrides the default value behavior of new. So remember when we said I wanted to create like an instance from the factory. To create a new object, I called $new. We're still going to call $new, but the default behavior is just like to kind of create, a new object with all the kind of the default values. Um, if you want to kind of change that, you can define the initialize method. Okay. And so this allows you to kind of have required fields, or maybe perform checks to see if the inputs are valid, things like that. Okay, so here's an example, and we are going to create a person class object. All right, and so this is R6 class. The class name is going to be person, and we store it back into person here. And then we have a list of public fields and methods. And so we have two fields, name and age. Okay, and then we give it one method, and this method is going to be initialized. And this initialize method is going to get called anytime we call $new. And so this initialize method says we're going to take in two arguments, name and age, so that we can kind of use them here. And we're going to do a couple checks, okay? Stop if not. We'll throw an error if any of these conditions are not true. So you give it basically a list of conditions. Everything has to be true, and it will continue. If any of the things in here are not true, then it throws an error and would stop if not. So we're going to check if name is character, and if it's not, we'll throw an error. We'll also check if the length of name is 1. So we want to make sure we get a vector of length 1. Okay, similar thing for age. We'll check if age is numeric. We'll throw an error if it's not. We want to make sure the length of age is 1. We'll throw an error if it's not. And if everything kind of passes, then we'll take name and assign it to self dollar sign name. We'll take the age and assign it to self dollar sign age. Okay, so here I can try to create an instance of the person class object by calling person dollar sign new. We'll take in the argument Hadley, okay, and that goes to name. And then if I try to say age is 38 and I spell it out, then it triggers the stop, right? Because it is numeric age is false. So error in this is numeric age is not true, and so then we get an error. Okay, so I'll call it again. This time I provide age is 38, the number, and that creates an instance of the person class, and we'll store it as Hadley. So again, now I have a factory. Okay, every time I push the button, we get a person object coming on the conveyor belt, and we'll call this person object Hadley, and it comes with the values Hadley and 38. Okay. Um, Now, when we have this person object, or whatever object we have, the default print method, outputs information like this. You get this. This is this to indicate the class. We have the person class, and then it gives us the list of the public fields. The public fields are age and name, and then the public methods we have clone and initialize. Okay. If we don't like the way this gets printed out, okay, like let's say we don't really care to have clone and initialize shown here, we can define a print method, okay? And this is going to change the behavior of how objects get printed. Um, so here I'm going to define person as an R6 class. So this will define a new version of the person class. I have the same name and age fields and same initialize method, okay? But now I add the print method, and this print method just says, hey, cat a few lines to the screen, cat person to the screen, and then to indicate it's a person class object, and then cat name with we'll get self dollar sign name and age, self dollar sign age, and then again return itself invisibly. So we will use that new definition of person, and we'll say I want to Hadley and 38. And then so now when I ask what is Hadley 2, we're going to assign that to Hadley 2. We get the new print method, okay? And this follows kind of the definition that we provided here. We want the information presented like this, okay? Now, this definition of person is different from this definition of person, which has this definition, right? So we have two definitions of what it means to be person, okay? And this Hadley 2 is defined using this definition of the person class, and then just Hadley over here is defined under this definition back here. Okay, so these are two separate objects with two different definitions. Okay. Um, it's kind of like, every year car companies kind of create updated models, right? So if you bought a Honda Civic in the year like 2020, okay, you'll get the 2020 Honda Civic, right? And then if you buy one this year, you'll probably get the 2025 Honda Civic, and the next year you would get like the 2026 Honda Civic. Okay. Just because the company updates the definition or the model or the style of the thing, it doesn't go back and suddenly update your car, right? When you bought your car, that is the version you have, and it's defined under what the Honda Civic looked like back then. Okay. And then future instances, get the new definition and things like that. Okay. So that first instance of Hadley was created with the R6 definition that didn't have the print method. Okay. Whereas Hadley 2 was created with an R6 class that does have the print method defined. Okay. And the methods are bound to the objects that were created. So the old object, the old Hadley object, doesn't suddenly get the new print method. Okay, so Hadley 2 has the print method and gets printed out like this. Regular old Hadley has the old method and it gets printed out like that. Okay, there's no relationship between Hadley and Hadley 2. They just happen to share the same class name, right? The 2020 Honda Civic has no relation to the 2025 Honda Civic. They just happen to have the same model name. Okay. You are working, as you're working in R to develop a class definition, having a whole bunch of different objects that share the same class name but different definitions can become confusing. So it's recommended that you would kind of delete the old objects with the old class definitions and redefine them with the new class definition. Okay. Um, so that's what we have. Okay, let's go back and take a look at the accumulator class. And here, this is just another way to kind of define uh, objects and classes and methods and things like that. You can also use $set, okay? So in your class definition, okay, you can use $set to kind of modify any of the methods or fields. So here I can define a new accumulator class, and I say R6 class accumulator. And this defines a new class. Now this definition has no public fields. And so here, if I want to have public fields, I have to set them. So we're going to do $set public. I'll give it the field name and the value, 0. Set $public, or I'm sorry, $set, we'll call public. We'll create a method called add, and then I give it the definition of what that function is. Okay, and that function add is going to take X, add it to itself, $sum, and then return itself invisibly. Okay. And again, if you do this, new methods and fields that you kind of create and add this way are available to future definitions and new objects then, but they don't suddenly get added retrospectively to any objects that were created or existed. Okay. Um, we can, like any other object-oriented system, we also have inheritance. Okay. And so we can have classes inherit fields and methods from another class. Okay. When you define the new class, you can make references to the superclass or the parent class um, by using super. Okay. And so here we're going to create a new class called accumulator chatty, and this is going to inherit from the accumulator class. And here the chatty just means, be verbose, output stuff to the screen as you're kind of working. So here we're going to say accumulator chatty is going to be a new R6 class. The name going to be accumulator chatty. We use the same name here and here. And we're going to say it inherits from the superclass accumulator. So this definition of accumulator here, where I have sum and add as public fields and methods, it's going to inherit those. Here we're going to change the definition of the add method. The add method is going to take in an argument x, and then what it will do is it's going to print something to the screen. It's going to cat adding x to the screen as it's working. And then we want to add X to the thing. Now, I could have just said like self $sum plus X is self $sum. I could have done that. But I can also just call the superclass, right? I can say, hey, use the method add. The method add already exists in the superclass, so we call super $add, and so it's going to call that, okay? And so here, if I create a new instance of the accumulator class, we're going to call that object x2. So I have another factory machine. I push the button. I say create a new instance of this thing. It's rolling off the belt. We call it x2. And so now I can say, hey, add 10. And then it a cat's adding 10 to the screen. I say add 1, it says adding 1 to the screen. And then what's the sum now? The sum is now 11. Okay. Um, and so, when we did this, we defined a method add that's going to override the definition of add in the superclass. Okay. But in that definition, we make a call to super $ add, and that's going to kind of call the original add method there. Okay. If you don't define a new method or a new field, it's just going to inherit and use whatever you have existing in the person class. Okay. When you have these R6 objects, and you ask what is the class, it's going to print this out. So if we ask, hey, what is the class of Hadley? It says that is a person class. It's also an R6 object. Okay, what about Hadley 2? Also a person class, R6 object. Now, keep in mind, this definition of person and this definition of person are different. They both have the same class name of person, but they are defined differently. The definition of, this one doesn't have the print method and this one does. Okay. Um, Here, when we ask what is the class of X2, it is an accumulator chatty object or class, which inherits from the accumulator, which inherits from R6. Okay, so you get that hierarchy of the different classes there. So we have accumulator chatty, accumulator, and then everything inherits from R6. Okay, question: could you go over why you defined super $add? Couldn't it just inherit it without the definition? I didn't define it. Okay. This is add. So we're not defining super $add. We're defining a method add. This method of add does this, and then it makes a call to super $add. So we are calling, not defining super $add, but we are calling $add, and we are going to use the definition of add in the superclass of accumulator. Okay. We are defining a method add here, and this is the method add that belongs to accumulator chatty, and it is a modification, right? It does something that that this thing doesn't do, in that it cats text to the screen. Okay. But then it just makes a call to the superclass. Okay. With with the object, you can also ask what are the names and fields that exist. Okay. And so here I can say what are I'm sorry, what are the fields and methods? Okay. What are the fields and methods? And to get the names of the fields and methods, you call names on that object. So Hadley is the old person class that doesn't have print, so it says, hey, you've got age, name, clone, initialize. Okay. Hadley 2 has the new definition, so we get age, name, clone, print, initialize. Everything comes with clone, even though we don't define clone. All R6 objects come with a clone, and I'll show you how that works. And then so X2 is the chatty accumulator, and we have the field sum and the method add, and these are all kind of the things there. Okay, let me give you your second view quiz answer, which is the letter D. D as in dog is your second view quiz answer. D. Okay, so R6 uses reference semantics, which is different from the rest of R. Okay, the rest of R uses copy on modify. And so, what we do is like this line of code, it creates a vector in memory. It creates an object in memory with the values 1 and 2, and we bind it to the name A. Okay. And then here we bind the name B to that object A. So both B and A right now are pointing to the same object. This line, however, will modify the first value of B, right? So we say take the first value of B, add 10, and then this line right here, this part says assign that result to the first value of B, okay? And so when R sees this, it sees that you are modifying B in memory, and and when it sees that, it says, I'm going to create a copy. Okay, so originally A and B are both pointing to the same object in memory, and then but at this line it creates a copy, and so you have A remains the value 1 and 2, and B, the copy, now gets the value 11 and 2. Okay. Versus with R6 objects, we have reference semantics. So here I'm going to create a new instance of the accumulator. So I hit the factory button, and object rolls off the conveyor belt, and we call that object X. Okay. And then here, Y, we have that object X. We're gonna call we call it X, and then Y also points to that exact same object. Okay, so now we're gonna say, hey, take X and also give it the name Y. So Y and X both point to the same object. So if I say, hey, add 10 to Y, we take that object and we add 10 to it. Okay. Because X and Y are pointing to the same object, if I say, hey, what is the sum on X? It's 10. And I say, what's the sum on Y? It's 10, okay? And that's because they are two names for the same object, okay? So we have reference semantics because X points to the object, Y points to the same object. Versus over here, at first A and B are pointing to the same object, but then when R sees you're going to modify B, it creates a copy. So you get two different objects now. Has 1 and 2, and B is something else, okay? Here, X and Y point to the same name or same object. So if you don't want that, we have the clone method, right? So here, I hit the factory button. It creates a new accumulator class. It's rolling off the belt. We call that thing X, okay? So X is a brand new object right off the belt. It has the value 0 right now. Rather than saying Y is going to point to the same object as X, we say make a clone of X, okay? So I take that object and I clone it. So now I have two objects. I have X and then I have its clone, and we're going to call its clone Y. So now we have two separate things. We have X and the clone. The clone is called Y. So to Y I add 10, and uh and if I ask what is the sum on Y, the sum on Y is going to be 10 because I added 10 to Y. If I say, what is the sum on X? The sum on X is 0 because it's a separate thing. It's a clone, right? I mean, this is the original, Y is the clone. So I added 10 to the clone, Y, but not to X. So, make sure you understand the difference between this and how, we have different objects there, right? So if you want to copy, or a different thing, you call clone. And all R6 objects inherit that method clone. Okay, reference semantics can be tricky. So this is just fictional code that we have no idea what is actually happening. But, with base objects in R, we don't have to worry about reference semantics most of the time. It just, our functions just behave as functions here. So we create we create a list, we call that X. We create a list, we call that Y. I call a function that takes X and Y as inputs, and that function outputs Z. Okay. And when you read this code, we know not like this function isn't going to modify X or Y. Okay. It takes X and Y as inputs, it creates something, and that new something is Z. Okay. But we don't have to worry about that. Okay. Whereas this fictional code, again, nothing is defined, so we don't really know what's happening. But if we have capital L list to indicate this is an R6 class object, okay, we have um, we have an object X, we have an object Y, and we have a function that takes X and Y as inputs, okay? However, we don't know what the code is inside this function. And inside this function, there could be calls that look like this, $add 10. Okay, I don't know. All right. There could be functions calls inside that function f that do something like this. And if we make a call to y dollar sign add 10, that would modify y. Okay, it would modify that. And so um, this function will output something to z, but we don't really know what's happening inside the function f. And so it is possible that when you run this, execute this piece of code, it it makes changes to x and y. Okay. So to avoid confusion, we recommend that when you write a function, it's going to do one of two things. It's either going to return a value, but not modify the inputs. Okay. Or it modifies the input, but doesn't return a value. And and if you kind of follow these rules, then that will help you avoid confusion when you read your code. Okay, so for example, here is a function that modifies that, executes dollar sign add 5, but this thing is not going to return anything. So this is a function that when I call it on X, it makes a call to add 5, and so X gets modified, but this function is not going to return anything. Okay, it just runs, it modifies X directly, X get modified in place. Okay, whereas this function takes a value from whatever argument we pass it, and it returns a new thing, but it doesn't modify it, right? So this asks what's the sum, and then we multiply it by 10, whereas this function back here actually made a call to a method that modifies it. So here I do sum times 10. So this outputs the value 50. I have to capture that value 50 and I store it as y. But x itself is unchanged. X dollar sign sum is still 5. Okay. Whereas over here, there's nothing and I don't have an output to capture. I don't, use this assignment operator. So this is an example of something that this function modifies x in place. This function does not modify x, but returns a new value. Okay, that covers what I wanted to say about R6. There's additional stuff on private fields and active fields. This stuff's not going to be covered on the midterm exam. You don't need to need to know it for your homework, but it is kind of interesting, and I kind of want to throw it in there. So we'll just take the last few minutes to do this, okay? I guess while we're here, let me go ahead and give you your last view quiz answer, which is the letter A. A as an apple. A as an apple. Okay, so far we've been just working with public fields, okay? Public fields are directly accessible and you can modify them, okay? Um, we have, we can also have private fields, okay? Private fields means they are not directly accessible from public. They are only accessible within the object, okay? Now, one thing to note is private doesn't mean secret or encrypted, okay? You can still kind of easily access those values, but you just can't like access or modify them directly. So here, this is our person definition. And inside this definition of person, we have public fields name and age. So I can use $age and retrieve that value, and we get 38. But I can also modify that value, $age directly. I can just say, hey, Hadley $age, and we're going to assign 25 to it. And I can do that. And then Hadley $age is now 25. And so that's kind of like, a little undesirable, with a public field is like you can just kind of like modify these things directly. So, one way to avoid this is you use a private field. Okay. And so here, I don't put name and age as public fields. I put them inside private. So I've got a public list and I have a private list. Inside private, I have name and age. And then in the initialize, we're going to take name and age and assign that to private $name and private $age. Rather than self $name and self $age, they get assigned to private $name and private $age. Okay. And then, our print method will access private name and private age. Okay. So if I define a person using that definition and I say, hey, give me age, it gives me back null. It says, you're not able to access these private values directly. Okay. If I try to modify age, okay, modify age gets this returns an error. Okay. It says you cannot add bindings to locked environments. So because these are private, so they're locked. But those values do exist. They are stored. We have Hadley and we have 38, and they're stored right here. Okay, but you can't. They're private, so you can't access them outside of the function. So that's a private field. Now, sometimes you want something in between, okay? And that we can do that, achieve that with an active field, okay? So with an active field, we can say, you know what, I want to be able to access the values like this. Like I want to be able to ask for $age, but I don't want to be able to modify it like this, where I'm going to do assign 25 to age. I don't want this, okay? So this is good where I'm trying to assign 25 to age and I will get it back in error. I want that, but I don't want this. If I want to just access the value here, I don't want it to be null. I wanted to get that back. So private says like you can't look at it, you can't modify it. Public says you can look at it and you can modify it. Active will allow us to give us something in between. We can say, maybe I want to look at it, but I don't want to modify it. Okay. Or maybe you do want to modify it, okay? What active does is it uses a function either to retrieve or to edit. And if you want to retrieve it, you can retrieve it. If you want to edit it, you can edit, or you can deny the edit and things like that. And so an active field will see like, are you trying to just get the access the value? If you're trying to access the value, then value is going to be missing. If you're trying to modify it using the assignment operator, then uh, the value is not missing. Okay, so active fields are functions and they take in one argument, and the argument is going to be value, and value is either missing or not missing. So here's an example of an active field, and this is just to demonstrate that the value that an active field shows is produced by a function. So this is going to be a random class, a rando class. Um, It has one field called random, and it takes in a function. And if we're just retrieving it, meaning the value is missing, if value is missing, then just generate a value using runif. Okay. If you're trying to assign something, we're going to say return an error. Can't set random. Okay. So every time I ask for $$ random, this is executing a function. Okay. It's executing runif. And so I get this value, I get this value, I get this value. All right, here is an example of how we can use an active field. So I'm going to create a person class. I'm going to have a public, private, and active. Okay. Under public, we have initialize. This will get created when it's new. Okay. We'll take name and age. We're going to assign that to private $name and private dot name and dot age. Okay. I've got dot name and dot age. This is intentionally we put the dot there to say that, it's like name and it's like age, but it's not exactly that. And this is just so that we can kind of distinguish between them. And then I have the active, and inside active, I have age and name. Age and name is going to be a function, okay? And if I have missing, this means I'm trying to retrieve it. If I'm trying to retrieve it, I call private dot age. This will retrieve the value, dot age. If I try to, if the value is not missing, then that means I'm trying to modify it, and then we're gonna throw an error that says, nope, you can't do that. We say stop, age is read only. Okay. Whereas the name, if it's missing, I'm trying to retrieve it, and we will retrieve private dot name, and we'll allow for that. If name is not missing, that means I'm trying to assign it, and we will actually allow for that also. We will say private dot name, and you can take the value and assign it there. So we will allow for that. We have a check to kind of check for validity, but we will check for that. Okay, so some notes, but we'll just kind of jump to it. So here, I'm going to create a new instance of person, and I call $name. I'm retrieving name here. Okay, I'm retrieving name, so we get it from private $name. Here I'm going to try to assign, and assigning name is allowed. So that gets passed in through here, and we take that name Wickham and we assign it to private $name. So that's allowed. Okay. If I say, if I try to assign the value 10 to name, then we get an error because there's a function here that checks. If I try to retrieve age, it's allowed and we retrieve the age. If I try to assign something to age, it uses this function and says, hey, you're not allowed to do that. And it throws an error. So active fields are kind of nice because they look like public fields, but they're actually generated using a function. So you can do things like check for validity or prevent people from modifying it. Okay. Whereas a public field, like you can just modify it directly. You can, with a public field, whoops, I could just change age to 25. I could just, put in completely invalid stuff right here. Okay, that is it for today's lecture. So we'll end here. I think I gave you all three view quiz answers. So we'll wrap things up there. Again, appreciate your flexibility in just meeting online. Office hours will be online only as well, and that will start at 10:30. All right, have a great rest of your day. Stay safe out there, and we'll see you later.